All right, let's look at this example. Use a linear approximation to estimate cosine of 60 degrees. This is a typo. 60 degrees is 1/2. So let's make it cosine of 61 degrees. All right, 60 degrees is going to be our A, the nearby number. And if you think about what cosine looks like this. So this is 90 degrees here. 60 degrees is over here. And so 61 is just barely past it. So cosine of 61 is going to be slightly less than cosine of 60. So it's going to be a little under 1/2. Now, one thing we have to do, we must use radians. So we've got to change this from a nice degree problem into something dealing with radians. And instead of just converting 61 degrees into radians, let's think about this for a second. One full trip around the circle is 2 pi radians, and that's 360 degrees. So I'm going to divide both sides of this by 360. And get 1 degree is equal to pi over 180 radians. So what I want to do here is use for my A, we'll use 60 degrees, which is equal to, let's see, 60 degrees, that's pi over 3 radians. So A equals pi over 3. All right, and we've got to plug into L of x is f of A plus f prime of A times x minus A. All right, so f of A, the function we're dealing with here is cosine. So f of x is cosine x. F prime of x is minus sine x. And let's see, f of A, in this case, that's f of pi over 3. That's cosine pi over 3, which is 1/2. And f prime of A, that's f prime of pi over 3, which is minus sine of pi over 3. So that's minus root 3 over 2. All right, so my L of x is going to be f of A, that's 1/2, plus f prime of A, that's negative, so I'm going to take the plus out. It's minus root 3 over 2 times x minus A, x minus pi over 3. All right, so this, I'm going to put a cloudy looking circle around it. That's our linearization function. But what we were asked to do is to find, or to approximate cosine of 61 degrees. Now, L of, let's see, 61 degrees I'll just put it this, cosine of 61 degrees is going to be 1/2 minus root 3 over 2. Now, this part in here, x minus pi over 3. Now, keep in mind, this is the difference between the value we're plugging in, 61 degrees, and our A. So the difference in 61 degrees and 1 degree, or 61 degrees and 60 degrees, is just 1 degree, which is pi over 180. So I'm going to put in pi over 180 here for this value. And now this is going to give me the answer. Now I do need to change one thing. Cosine of 61 degrees, this is my approximation. So let's see. I'm going to stick this all into my calculator. 1/2 times √3 over 2 times pi divided by 180 when I put that in here, I'm going to make it look like this. 1/2 times √3 over 2 times pi over 180. It gives me this. Now I'm guessing, well, it doesn't matter. I get 0.00755. Oh, I see the problem. I did 1/2 times. That's supposed to be 0.1/2 minus. And what do I get? When I put the right thing in there, I get 0.48488, etc. Now, when I did that the first time, I knew the answer was wrong. And I was about to blame it on my calculator being in radian mode instead of degree mode or something. But that doesn't matter because there's no trig function in the expression I've got up here. No trig function means it doesn't matter which mode it's in. That was going to be wrong regardless. So we get an answer of 0.48488. Now just for comparison, let me make sure I'm in degree mode this time because I am going to use cosine. I'm going to do cosine of 61 degrees. When I put that in there, I get this number, which is pretty close, down to 5 decimal places, it looks like. Actually, no, to 4 decimal places. But anyway, that's how you would do this type of problem. All right, next up, we're going to talk about differentials, and I'll save that for the next video.